MultiModel research. And tonight we're going to talk a little bit about text. The question is, what do you do with text? So did you read all that? You didn't, because there's too much text. There's too much for humans to read, but computers don't do a very good job reading it. So the question of the night is, how do you use text to increase revenue, lower cost, and save lives? Okay. So, multimodal research is a platform for machine learning with an emphasis on text. We're able to elegantly use both structured and unstructured data. Lots of systems either have an emphasis on text, like natural language processing, or structured data, but not both. And we do this with a patented way that we transform text for use in fast machine learning. That's what we call no NLP, like no SQL, because it's not natural language processing. Our initial traction is in healthcare, where we read medical records text. So you may not be aware, but your medical record has lots and lots of text. It's not uncommon for there to be 20,000 words of text in a medical record. That's doctor's notes, nurse's notes, lab summaries, pathology summaries, radiology, and discharge summaries, and so on. We use that text to create models which predict things. We predict billing codes, which is kind of important because the providers of the medical services would like to get paid. So we are able to take the text and go directly to billing codes instead of using structured data, which most companies use. We are also looking at the risk of readmission to the ICU, which is a big cost driver, and clinical decision support, predicting acute conditions before they happen. So with that, I'm going to take you to the demo. Now, the first part of the demo is we take some text and we tag the text. And in this case, it's a financial services, financial news demo. So we take a financial news story and we run 500 models on it, one for each of the tags, and we see which tags raise their hand. But there's another half of the demo, which is our models can run in reverse. So we can select the tag and see which text actually pointed to that tag. That's quite important, especially in medical records, for instance, where you have to show justification for making a claim the way you did. So let me switch to the demo. So this demo's out on the web. You can do it yourselves. So all you do is you take some text. So here's a story from CNBC that I just picked up. So I'll just copy the text. Hit classify, and that runs 500 models against it, unless it's blocked by the firewall. Blocked by the firewall, Chris. Well, unfortunately, I'm not going to be able to show it because the firewall just clicked back and stole our IP address. So you can do this out on the web yourselves. So I'll tell you what you would have seen. As you saw on the slide, you should see a series of labels for that story, and then you can select one of the labels and it will highlight on the other side which text pointed to that label. So I welcome you to try it out on the web and or discuss with us some of the healthcare applications. I can't show the healthcare demo because of HIPAA. So thank you. Happy to take questions.
Who creates the models and how?
So the models...
Can you repeat the question?
I'm sorry. Who creates the models and how? The models are machine learned. So we have an API that you send training data to, So you say, here's some text, and here's what the answer should be, the tags should be, or whichever, and it learns. And then you're able to query that over the API. You send it text, and it comes back with these are the tags and the probability that those tags are the right tags. Answer your question? It's
I'm sorry, I missed it. The probabilities of what?
the probabilities that the certainty that we have those tags are the correct tags. So again, we're running, in this case, we're running 500 models in parallel, and we give back top 5 or top 10, but with information about how sure we are that those are correct.
I'd like to ask a follow-up if I may.
Sure, please.
I'm using terminology and I'm not sure exactly what it means.
Okay.
So let's take the case of a visit to an emergency room where voluminous amounts of text was generated.
Correct.
Then somebody's going to take all that text and run it against how many models? Because the number of possible codes in ICD-10 is pretty large. And you're saying there's a model for every single one of those? Is that the way this thing works?
So the question is, can we scale out to the tens of thousands of models that you find in ICD-10, for instance?
Well, actually, the question is really, do you require one model for every possible outcome? And if so, how do you scale up?
So in coding, yes, we do one model per ICD-10 code, which can be tens of thousands of models, depending on the training data. And the power of very fast modeling and the power of the way that we handle text is that scale out is quite easy. So the way we scale out is you send us training data with the tags, and if it's a new tag that we haven't seen before, we create another model in parallel with the other models.
Great job. Sounds really interesting. What platform are you using for the machine learning model? Do you know?
So the machine learning itself is in Python. And the machine learning algorithms that we use, as our founder says, it's whatever machine learning you have running around the house. So we use a lot of ridge regression. We don't do deep learning most of the time, or ever actually, because deep learning requires a lot of data. Deep learning doesn't scale out nicely, whereas something like ridge regression is provable that it converges quickly on a solution.
Then when you were talking about reflects on billing, and you actually do a diagnostic work in an emergency room or something else.
So the question was, the demo was references billing, and can we do something similar in the emergency room? We actually have a proof of concept right now at Bay State Hospital in Springfield, where we're looking at the ability to predict acute conditions before they happen, and specifically sepsis, which is a major problem in hospitals. 700,000 cases a year in the United States of sepsis, and it's the #1 cause of hospital mortality. So hospitals pay a lot of attention. So we're looking at our ability to look at the text records and give 4 or 8 hours of warning before sepsis would be onset. The next step after that, because hospitals don't really have good predictions now, is what do you do with them? So the first part of it is, can we predict it, which we believe we can. So yes, we can work in a clinical setting. The disadvantage of working in a clinical setting is that from a startup business point of view, that gets difficult because it's FDA involved. So coding is a lot easier because it's not actually delivering the healthcare, and there's a lot more direct money associated. I got time for one more quick question. Go ahead.
Yeah, I think it's a really interesting idea. I'll be very curious to understand like the actual difficulty, the challenge of this technical problem. I mean, what you're demoing here is more like understanding semantics of the passage, and what you're trying to tackle business context more about evaluating risk at ICUs, for example. Like I would love to know like if there's like benchmark, like how hard it is, say just use simple features like simple semantic features to test it and see like how much you can improve on that.
So I'm out of time, so I'll give a very quick answer, which is that we work across the whole text instead of the semantics and trying to do natural language processing on the individual sentences or features that are in the text. So by working across the whole text, we're able to create answers either for risk or for individual codes.